Where are you in the race for modernizing your infrastructure for hybrid cloud? Here to answer that question is our next keynote speaker, Sam Werner, Senior Storage Product Executive from our Platinum sponsors, IBM. Let's hear from Sam.
Hi, everyone. My name is Sam Werner, and I'm the Vice President of Product Management for IBM Storage. I'm really excited to be at SODACON 2021 this year. And today I'm going to be talking to you about the importance of modernizing your infrastructure in support of your digital transformation and hybrid cloud initiatives. I'm going to have particular focus on storage, my favorite area of infrastructure. So first of all, what do we see happening in the world? Enterprises are on an accelerated path to digital transformation. They're working on building applications and becoming more agile, leveraging DevOps to more quickly respond to client demands. And also, in light of the pandemic and everything that's happened in the world, be able to alter the way they work internally, the different ways we interact every day. So this requires much more agile response and application development and deployment. That actually includes infrastructure as well. So as enterprises start on this path of being able to build an application once, deploy it anywhere, accelerate deployment, they need a diverse and easy set of tools to use and capabilities that enable that build once, deploy anywhere type of model. Now, what they find as they start doing this, building out these DevOps environments, it becomes challenging to match SLAs across different environments. The idea of being very agile requires the ability to meet SLAs no matter where you go, but most importantly, being able to achieve the security requirements and governance requirements you have. And in particular around your data. How do you secure your data? Ensure you're compliant with things like GDPR and that you're matching the regulations that go with your particular industry. So that's what I'm going to talk to you about today. What we find is as enterprises are on their journey of digital transformation, those that don't really think through the architecture, particularly down at the storage layer, find their initiatives are stalling or even failing because they didn't think through the impacts of data. And I'm going to talk through a few different categories of that. I'm going to talk about data movement, access to data, and most importantly, data protection. So first of all, data movement. We talk about build once, deploy anywhere. If your data is locked into a single location, it ends up being build once, deploy where your data is. You don't have the flexibility you expected. So, I mean, in the early days of containers, most of the applications were microservices and they were stateless. Now, as we go through this transformation and start to bring the other 80% of applications, data becomes critical and the applications become stateful. And so you have to have a way as you provision an application, as you spin up an application somewhere to get at its data. So that's really important. Also, if you want to move applications to different locations and provide that flexibility, whether it's deploying an application at the edge in a public cloud or on-prem, you're going to need some level of app mobility. So that's something you have to think through is data movement in order to realize that vision of flexibility. For example, you need to spin up additional capacity because requirements on your IT infrastructure increased. You decide to deploy that additional workload in the cloud. If there's data dependency, how are you actually going to get the data there? And as you move up and down, scale up and down, where does the data ultimately get stored? So do you have a strategy that talks about where the primary location of data is? Obviously, if you're spinning an application up and down, you need to make sure you don't lose track of your data. Data access, building off of that. Most of you have significant investments in your own storage infrastructure and have a lot of data in there. How do you actually unlock that data and build out these new applications leveraging what you have? You obviously don't want to throw everything out and start from scratch. So how do you actually integrate it? And so we're talking to you about modernizing your existing infrastructure, help you accelerate your provisioning of storage and access to existing data. But in order to do that, and actually, in order to become truly agile, you want to give a lot of this to the developers and allow them to provision their own storage. So you have to have a very clear set of common APIs that are consistent across your storage infrastructure so that the developers are able to manage some of this themselves. Otherwise, you're really not gaining much through moving to a containerized infrastructure. Now, the last area, and definitely one of the most important, is around data protection. So data protection includes lots of things. It includes backup in case something happens to data and you need to recover it. Yeah, it could be just somebody accidentally corrupting something or making a mistake and deleting a file. But it also could include some malicious act, for example, a ransomware attack, and you need to recover the application from the backup. So how do you do backup? And how do you do backup in a way that is application consistent so that when you restore it, you can actually stand your application back up? Then really important around high availability and disaster recovery. If you're starting to move core applications that your business runs on day in, day out, you can't afford an outage if there's some sort of a disaster. You want to continue running. Some applications have a recovery point objective that is very quick. So even as low as 0. And a lot of you might take advantage of capabilities like Hyperswap, which give you continuous availability, even in the event of a disaster or some sort of failure. So in a containerized environment, that's all very new. It's fairly mature, still complicated to do in bare metal and VM environments, but in containerized environments, a lot of this isn't fully consistent or baked across all your different applications. And then you have to imagine your application isn't necessarily going to be 100% containerized or 100% VM. You might be somewhere in the middle. You might move the front end of an application into a container to speed the scalability of it or the development of the capabilities, but a database might still be running in a VM or bare metal. Now, how do you do a consistent backup in a hybrid environment like that? I don't mean hybrid cloud. I mean an environment that's part containers and part bare metal or VMs. So you need a strategy to be able to back up in that kind of an environment. And once again, maintaining application consistency in the event you have to recover. And then, of course, as you move into this new architecture, you have to ensure you maintain security, governance, et cetera. Do you have appropriate encryption policies across all of your data? So these are all things you need to think about. So a lot of times we'll see an enterprise get started on this, move into a DevOps model. We're doing digital transformation. We're refactoring our applications, but they're not architecting a storage layer that can handle the vision of the architecture. So you got to focus in on the storage. This becomes a big inhibitor if you don't. So what are storage vendors doing? Well, it started off by container enabling storage, and this is still a very critical component in enabling this transition. This is introducing things like CSI drivers, container storage interface. This is the de facto standard API for integrating into Kubernetes. This allows for the automated provisioning, orchestration, monitoring of storage infrastructure, usually connecting into very well-established storage products that you probably already have in your data center. Then we saw storage vendors begin introducing container native storage. This would run directly within your Kubernetes cluster, and it would be provisioned dynamically with your cluster, leveraging different types of storage, whether internal disks and servers or externally attached storage. This is good. It improves efficiency and availability and some of the automation. But in a lot of cases, there's some immaturity around things I talked about previously, like data protection, disaster recovery, et cetera, that a lot of your more traditional storage that you already run in your data center can already do. And some of that can be orchestrated through CSI drivers directly. Where we see things going, though, is moving more towards a data-aware infrastructure. And actually, this is where either the application has awareness of the storage services, or the storage services have awareness of the application so that you can have application consistent backup DRHA so that you can have data mobility and the applications are aware of where their storage is. And we're talking, we call this data service APIs, and there's lots of ways to achieve it. I'm going to talk about the way that we view this now. When we look at what we consider an enterprise storage architecture for next-gen applications, we look at it in 3 layers. Starting at the bottom, this is where the storage administrator is focused. As we work our way up, it's where the application developers interact with the model. So first of all, it starts with the storage platform. Storage platform, at its core, provides you durability of data. It puts it on media with the best possible economics, with a performance that meets the requirements of your application. Low response time, high throughput, high bandwidth, depending on what your application requirements are, and provides core storage functionality like snapshots of data, which allow you to create point-in-time copies in case you need to recover. Above that, we have our layer 2 storage services. This is where your DR orchestration, high availability orchestration comes in, data cataloging, backup, et cetera. This is where those core services and SLAs are met. And this is where the integration happens or needs to happen with an application runtime environment. What you would ultimately like to do is abstract the storage layer, provide a set of services that application developers can tap into and integrate directly into the application they're building. So you don't want to have every application developer having to build out their own methodology and way of doing high availability. Instead, you would like them to integrate with a single API and service that provides that. So you can provide a set of SLAs up to the application developers, and they can build that into their application without having to have complete awareness of the storage. So this works as an abstraction. So as you start thinking about these storage services, what am I talking about? I'm talking about data resilience. I'm talking about having integration for data protection that allows you to take a container-aware snapshot and application-aware snapshot of your data so that if you need to recover, you can get back to that data. Remember, applications can be complex. It's not a one-to-one mapping of an application to a container. So you have to know where the data is, which data needs to be snapshotted together. Capacity and performance management. Again, not a one-to-one mapping. This can be more complicated. You might be running across multiple different environments, including in a hybrid cloud. So how do you give visibility to the application developer on what kind of performance they can expect and give them the ability to provision the right kind of storage that they're going to need? Discovery and orchestration. Orchestration is key, but also understanding the data, where it is, where it's been, and how to access it. HA and DR, I think I've talked quite a bit about it. High availability and disaster recovery are critical for most applications and absolutely critical for any persistent application. Security and encryption, I don't need to tell you how serious security and encryption are with all the data breaches you see in the news and the different types of attacks we see every day. Security has to be at the front of your design for your storage architecture. And then migration, I talked about this desire to build once, deploy anywhere, the ability as I need additional infrastructure to deploy it where it makes the most sense, requires the ability to move data to where it's needed and do that in an automated way, because having to copy data around is inefficient. You prefer to have some sort of a caching type of methodology that gives you the ability to easily move data to where it's needed. And so when I look at it in kind of a simple picture, we take the layer 1 storage platform. In our case, we provide, and when you think about what some of the requirements are, you need global access and enterprise-ready storage, providing simultaneous multi-protocol access. Let me tell you what that means. You might have some applications that are new, that were just developed, cloud native, they use an object storage API. You might have some traditional applications that are using NFS protocols. Do you want to have to refactor all of your applications to speak the same protocol, or would you like to be able to have different applications get access to the same data using the different protocols? The other alternative is to make multiple copies of data, and that's inefficient and also creates additional security and governance exposures. High performance storage caching, allowing the data to be available where it's needed. The ability to archive data to more efficient long-term storage medias like tape or to an object storage in the cloud. And of course, being optimized for AI. I'm sure all of you out there have AI initiatives underway, trying to build up insights from your institutional knowledge to provide more value to your customers. It requires very expensive infrastructure to do that. And data scientist productivity is also a very critical expense. So optimizing for AI use cases is key. So high throughput and deep integration into GPU-enabled servers. And then, of course, for security, having storage which has immutability. And when I say that, I mean the ability to create read-only copies of data. So they can be read, but they can't be changed, which means they can't be encrypted or deleted. And of course, by the way, when I say encryption, I mean encrypted by something like ransomware. And of course, being able to encrypt your data to protect it. And then the layer 2 storage services, we layer in all those capabilities I was just talking about on the previous chart. And all of that then integrates northbound into Kubernetes. And we have a particular focus on our team with Red Hat OpenShift, but we support all Kubernetes, major Kubernetes distributions. And that gives you the ability to integrate into the application runtime management. So in IBM, what we've built is something that we call IBM Spectrum Fusion. This is container native storage built from the ground up to solve those big problems that I talked about. This brings the enterprise class capabilities that enterprises expect as they deploy their most important applications, but done in a way that's efficient and abstracted for container environments, allowing it for it to be in an automated way, deployed, provisioned, scaled up, scaled down, along with your Kubernetes cluster, but also giving you the ability to create a common deployment model on-prem, in the cloud, and at the edge, with the ability to access the same data in any of those locations using our own unique active file management, which gives you the ability to have one single namespace of data no matter where you deploy. So if I were to deploy IBM Spectrum Fusion on premises, put all my data on there, stand up my applications, then I decided to deploy another application on a public cloud, let's use AWS as an example. I could spin up IBM Spectrum Fusion, and all of the data running on-prem would be available running in AWS, and the data needed would be cached in automatically. If you're running applications at the edge, it can work that way as well, and you can connect them in any different way. All of this integrates into Red Hat OpenShift. Like I said, we'll also support other Kubernetes distributions, and we're building an ecosystem on top of it to make it really easy to deploy your full catalog of applications on top of Kubernetes. So Spectrum Fusion will be available across all the major public clouds, and will also be available to be deployed in your own premises or at the edge. Our first instantiation of it, to make this very easy for you to get started, will be done as a HyperConverged Appliance. This is a container native, built from the ground up, HyperConverged Appliance, completely turnkey, drop it in, deploy OpenShift, and you've got a turnkey DevOps environment ready to be deployed. This will be generally available at the end of September. And after that, in a future release, we'll make a software-only version available for you to consume on-prem on your own hardware or on a public cloud. So this will give you the ability to deploy our HyperConverged Appliance at the edge in your data center, or deploy the software only in a cloud and create one single platform with one consistent data management across all the locations across your entire environment. So I know I covered a lot in a short amount of time. Actually, if I had more time, I could have gone a lot deeper on some of these concepts. If there's one thing you take away from this, it's that a lot of times the initiatives to do digital transformation, in fact, in most cases, it starts with the application development teams. and they build out an architecture on Kubernetes. They make a lot of decisions on their own without thinking about all the implications of the infrastructure, particularly the storage. So I urge you all to think through some of the challenges that I've highlighted here today and how you're going to address that storage architecture to ensure that whatever your initiative is doesn't get stalled or doesn't fail or doesn't produce less than optimal results in terms of agility because you didn't completely think through the implications of this architecture. So with that, I'm gonna pause here and I'm gonna open it up to questions. Hopefully you have some good ones. Like I said, I know I went into a lot of different areas around modern infrastructure, but I think we can have a good dialogue now. Thanks.
Thank you very much, Sam, for that session. I believe we have one question very quickly. How does migration happen from on-premise to public cloud? I mean, is it a data transferred in chunk or in the form of a stream?
Yeah, it's a great question. This is built on a technology we have in our portfolio called Spectrum Scale, which has the unique ability to deploy the same file space or a file system or namespace in multiple different clusters. So you can have it running on premises and in the cloud at the same time. Now, if you go to access a particular file in the cloud, it will automatically cache the data into the cloud. So it'll copy that file in real time and you have access to it. And it'll manage that through something we call active file management. So hopefully that helps answer that question.
Yeah, I believe what has happened is we are actually way out of time on this session because it was a 15-minute session, but the session itself was quite interesting. Thank you so much, Sam. We do have some questions. We will take them up and we will ask them at a later time. But at the moment, thank you very much for joining. Thanks again, Sam, from our platinum sponsors, IBM, for joining SODACON 2021.
Thank you.
Yeah, with that, now let's move on to the next keynote of the day, and that is going to be by Richelle Alves. I request everybody to please join the session, which is posted in the schedule. We will be ending the session now. Thank you very much.